Now, just as a FYI, I had a COVID shot yesterday, and I don't do well with COVID shots. It's a brand new one that came out last week. So if you haven't updated your COVID, it would be good to do that. Because I've had, over the summer, I had 12 students with COVID, 4 of my personal close friends, and 2 not so personal friends. And then my daughter and son-in-law all had COVID over the summer. So it's back. Now, how everyone's going to respond to it, but all I'm saying is, if you believe in vaccines, I'm a scientist, I do, the new one is out. So, and I go to the pharmacy at Costco and they have plenty of it. So I highly recommend it. Okay. Okay. 4 steps again. Balance the chemical reaction if there is a reaction. Now, Unit 1 is not going to have any chemical reactions. We're going to be using this throughout the rest of the semester, though. At the end of Unit 3, big time Unit 4 and 5, though, there's going to be chemical reactions going on. So you'll need to make sure that's balanced. The reason for balancing the chemical equation is in the middle of your calculations, you need to have some ratios from the balanced equation that will go into the calculations. So it's a very important step. Okay, then what's given? To figure out what's given is you look for the number and the associated unit with it. What are you trying to calculate? And then you do the setup with conversion factors, which are all fractions. Okay, so let's look at some of these. These are all going to be 1 step, but you can have up to 12 steps. Now remember, for test 1, you're going to have a take-home problem, and that's going to be a very long multi-step problem. But it's just the same thing. What's given? What are you trying to calculate? And what are the conversion factors that'll get you there? It's like a little game you're going to be playing. How do we get to the end? Okay, so how many inches are in 34 centimeters? All right. This is page 1 of the digital version of DryLab 2. I just enhanced it quite a bit, actually. I bold-faced instead of italicized the defined conversions, meaning they have infinite significant figures, and also expanded upon the metric system here. Now, some of these you're not going to use very often. You're going to get this on your test, by the way. You don't have to memorize these. And the part that the metric conversion gives students a lot of trouble. And so I'm going to go over that quite a bit today. Okay, so how many inches are in 34 centimeters? Okay, so what's given? I guess I should plug in my tablet here. Yes, on your take-home problem. You're gonna have lots of them. So you have to go through and figure out what's, yeah. There's a whole page of conversions, and most of them are superfluous. You're gonna go through, oh, I need that one, I need that one. I suggest using a highlighter. Yeah, it's your take-home problem. Like I use these assumptions for all my take-home problems. So there's things like how many calories in a standard diet for an adult? Well, 2,000 calories. Do you need that in calculating how much ice is produced when a jet flies to LA? No. What is the size of the Sahara Desert? Because we did a conversion on looking at what's the size, how many solar cells you need to power the world in the desert, But ice produced going to LA? No. So, but you're going to be, the reason I do that on purpose is because you're exposed to this stuff every second of the day with your phone. I mean, you're just getting tons of stuff. Some of it's germane but inaccurate. Some of it's accurate. Some of it's old. And you just have to go, I don't need that. Yeah. When you're looking at conversion factors, look at what's given as a first run through. And then secondly, what are you trying to calculate? The second run through. And then the other problem is if it's a multi-step problem, you're going to need stuff in the middle. But start with the given, start with what you're trying to calculate. And those highlight those for sure. And even them may not be usable because you may be trying to calculate centimeters and there's miles to centimeters, meters to centimeters, nanometers, which one of those do you need? Well, there's an intermediate step that's required there. So, and there are many times steps to get the right answer, but not necessarily one way to do it. That's another thing to keep in mind. Yes, I do. Every school I work at as a department, including physics and engineering people, we set things up this way. Every one. And when what's your next chemistry class? Whether it's 1A, 2A, or 3A, or not at all. Okay, is it an allied health track? Okay, it can be 2A and 2B, probably. Right in the beginning, they're going to be talking about the same stuff. I mean, and the way they want you to set it up, it's just like your book, and the way we're doing it in here. So if you learn it this way, you're in good shape. And let me tell you one other thing. A lot of you have a good background in math. You're very comfortable with math. And you're looking at this problem here and saying, now, why in the world do I need to set it up the way he wants me to set it up? I still got the right answer. If you got the wrong answer and I couldn't follow your logic, guess how many partial credit points you're going to get? Zippo. If you set it up, but just mess up with your calculator, you'll get 90% of the credits. Now, if you did it a different way and I can follow your logic and you messed up on your calculator, I can still give you partial credit. But if I can't follow your logic, you're not going to get any partial credit. And that's also why I don't do multiple choice. Multiple choice, it's either right or wrong, and that's it. So on the take-home question, is probably going to be worth 25 points. And there's a lot of area there for partial credit. So, okay, so, all right, so the given is going to be, why isn't this turning on? I'm having my challenges lately with technology. This is plugged in. This has never failed me. Oh, This is an old setup. So there are a lot of extra switches that you have on this thing that aren't needed now. And if you cleverly turn them off, there's no power going to a certain place. Anyway, it's working now. So, okay. So the given is 34 centimeters. And we're trying to calculate inches. Okay. So first thing is looking for centimeters and inches. If you can find a conversion factor with both those in it, it's a one-step problem. Otherwise, it's going to be a multi-step problem. 2, 3, 4, whatever. Okay, so we have that guy there. 1 inch is equal to 2.54 centimeters. It's bowl face. So that means it has infinite sig figs. Now, the given always has to cancel. No exceptions. So make sure whatever the given is on the bottom of that first conversion factor. And we have so our answer is going to have 2 sig figs. That's about as simple as you're going to get. Okay, how many miles are in 12 inches? By the way, going back up here, I want you to analyze your answer. Is this a reasonable answer? So on your ruler, you've got centimeters on one side, inches on the other, and there's always more centimeters than 1 inch in 1 inch. So in this case, it's 2.5 inches, 2.5 centimeters in an inch. So if you've got 34 centimeters, you've got to have a fair amount of inches. So 13 is a reasonable answer. In this next one, we have how many miles are in 12 inches? Well, would you say this is going to be a small or big answer? Very small. Miles really long. Inch isn't very big. Okay, for sure the inches have got to cancel because it's a given. Okay, so let's get our conversion factors. And we have inches in terms of centimeters, inches in terms of feet, feet in terms of a mile. Okay, so if we went to feet and then feet to a mile, we can get to where we want to be. Okay, so how many, this is a hard one now. "12 inches, right? By definition, that means it's infinite. Okay, now we're at feet. Now we're going to use this guy over here, the 5280. So everything cancels except what we're trying to calculate, miles. And again, you can leave this and go to the next problem on the test. Just have your setups all done. And if you have a little bit more time, you can go back and start using your calculator. But remember, the setup is worth 9 out of 10 or 90%. So if you run out of time and you have all your setups down, you'll still get an A, assuming the setups are correct. You'll still get an A in the test. But if you started doing the calculations and got frustrated with your calculator and ran out of time, you might get a significantly lower grade. Okay? So just FYI. And this goes for your next chemistry class. If you take physics, same thing. If you take engineering, same thing. One other thing. Some of you do intermediate calculations. My opinion, you should not do that because it leads to a potential transcription error. Keep it all in your calculator in one calculation. So what we're going to do is going to go 12 divided by 12. That's a tough one. And then hit the divide button again, 5280, enter. There's no intermediate steps needed. Some of you multiply this, you get an answer, then multiply that, you get an answer, then do an additional calculation. Theoretically, you should get the right answer. But you also have the potential for doing a transcription error, especially if you're dyslexic, especially. Okay, so we've got, oh, my battery is low. Oh. Technology. Okay, so assuming this wasn't 12, let's say it was 14 or something like that. So we're going to go 12 times 1 times 1, the ones we don't have to worry about. Hit the divide key 12, hit the divide key 5280. Okay, so 2 sig figs, infinite, infinite. So 2 sig figs in the answer. So is this a reasonable answer? Is this a big or small number? Really small. And we know it, the answer should be really small because miles are so much bigger than inches. Now, when I put this in my calculator, mentally I said 12 divided by 12 is 1. So I didn't put any 12s in. I just said 1 divided by 5280. Oh, let me review one more thing. If we're starting with a non-fraction number, you're going to end with a non-fraction number, like we've been doing so far. If we start with a fraction, though, as the given, we're going to end up with a fraction. When you're reading these word problems, whenever you see a per, PER, automatically in your head think conversion factor because it's a fraction. So a lot of your problems on Dry Lab 2, they don't necessarily give you the conversion factor. They'll give you some other data in there that ends up being a conversion factor. And then lastly, if we're doing measurements, linear to linear, feet to feet, inches to inches, okay? Not something like square inches to inches or cubic inches to inches. They've got to match. So we're going to go square to square. When I say square, I'm talking about like square meters or square inches or whatever, and then cubic to cubic. Now, the first one, linear to linear, is the one we've been doing. But I'm going to show you how to do the ones, because you've got to convert the linear conversion factors to squared conversion factors to cubic conversion factors. Okay, one real last one. Centimeters and 1.23 kilometers. Okay, so our answer, is it going to be big or is it going to be small? Going to be really big, because a kilometer is like a fraction of a mile, and a centimeter is a little bitty thing, a little less than half the size of an inch. So there's going to be a whole bunch of centimeters in there. So make sure when you get your answer, it's a big number. So is there a conversion factor going from kilometers to centimeters? If you go online, you'll find one. But on the test, you're going to have this conversion sheet in front of you, and your phones cannot be on unless there's an emergency or something. Okay, so what's our intermediate step here? Meters. Now, when you're using metric conversions, you're going to have a big number and a little number. Always. A conversion factor that the top is equal to the bottom. The numerator is equal to the denominator. So if meter is smaller than kilometer, so that means we have to have more of them to get the 1 meter. So a lot of mistakes over the years I've noticed, students will put 1,000 kilometers in the bottom and 1 meter on top. So just look at the conversion. If it's smaller, put the big number in front. If it's bigger, put the smaller number in front, because they've got to be equal. And kilometers is on the bottom. This has got to cancel. And now we're at and how many centimeters are in a meter? How many cents are in a dollar? 100, right? Okay. Again, centimeters smaller than a meter has to have the bigger number on top. Now, the other way to do this We can also use negative exponents. The ones we've been using are the ones over here. You can also use negative exponents. You'll get the same answer. Which is smaller, 1 or 10 to the minus 3? 10 to the minus 3 is smaller, so it goes with the bigger unit. 1 is bigger than 10 to the minus 3. So that is the same conversion as this up here. And the same goes for this. Oops. You're going to get the same answer. Now, some of you vote. Let's vote. Which version do you like better, top or bottom? Let's say, raise your hand if you like the top one better. Yeah, I think that gives students less trouble if they don't use negative exponents. So when you get a conversion sheet over here, that's got negative exponents and non-negative exponents, which do you use? You can usually use non-negative exponents. Just make sure that when you're looking at the numbers, the smaller unit has to have the bigger number in front of it. The bigger unit has to have the smaller number in it. Otherwise, you need to flip-flop those numbers. Now, you can thank Ronald Reagan for stopping our metric conversion in this country. We were going full bore, converting all the road signs to be kilometers per hour and all this stuff. Cars came out with KM on their speedometer as well as miles per hour and all that stuff. And then Reagan said, I don't like that, and killed it. That was back in the 80s. You know, there are 7 countries in the world that don't use metric system. One big one, and all the rest are these tiny little countries. And they use the British system because there used to be British colonies. But we're the only big country that uses metric stuff. When I lived in Washington about 20 years, and I bought a truck up there. A lot of the trucks in Washington are Canadian built, and Canada uses the metric system. So when I got a new battery put in my truck, and it was still under warranty, but when it powered back up, everything was in kilometers, and the service advisor told me my truck was not in warranty anymore. He says the mileage is way off, and I said it's kilometers, not miles. So I did the setup and converted. He said, "Oh, okay." Could not believe that. Anyway, enough of my stories. Okay. Okay. Are there any questions about this guy? All right, so let's do a fraction to fraction. Okay, if this car is speeding at 34.4 miles per hour, what's the speed in kilometers per second? Okay, here we have the per now. Whenever you see the per, think fraction and conversion factor. And remember, there's always two conversion factors. The inverse of one is the other one. Okay, so we have, so the given is a fraction. So we have to end with a fraction. So we have and whenever we have a fraction to fraction, it's two problems. You need to solve the top one, solve the bottom one. And it doesn't matter which you do first. Okay, let's do the bottom one first. And we need to get hours to seconds. So this is a tough one. How many seconds are in an hour? Well, how many minutes are in an hour? Got my eraser out. Did I do something wrong? Yeah. The given is not canceling. So HR has to be on the top. Okay, so hours cancel. Now we're going to go from minutes to seconds. Minutes need to be on the top, so it cancels. Okay, now we have seconds on the bottom. Now we're going to convert miles to kilometers. So if we look over here, we have miles to kilometers, 1609. So the miles cancel. So what are we left with? We're left with kilometers per second. Everything else cancels out. And what are we trying to calculate? Kilometers per second. So 1.54 times 10 to the minus 2 kilometers per second. Well, again, fraction to fraction, linear to linear. Now, this can be interpreted, let's see, let's do another problem of fraction to fraction. Trying to remember the one in the dry lab. Who's finished dry lab 2, curiously? Few of you, okay, good. I don't remember what it was exactly. Let's see here. Okay. Plane burns 34 liters of jet fuel per second. It is fueled in Canada, but then stops in LA for fill up. What is the gallon per hour of jet fuel that would need to be calculated? Now, this is typically what pilots will do. They want to make sure they get the proper amount of fuel. Yeah. On which one? Let me just redo it and make sure I get the same answer. So curiously, how did you do this problem? Right. But I did it that today as well. So everything on the bottom hits the divide key. So how many numbers are on the bottom? 2. That means you can hit the divide key twice. Everything on the top you multiply. So you go 34.4 times 1.609 divided 60, enter. Yep. And you get the same answer if you just multiply everything on the top, wrote down the number, wrote everything on the bottom, multiplied it out, wrote down the number, then do another division. You get the same answer, assuming you didn't have any errors, because that's what the calculator is doing internally. So that's the way most people do it until they have me for a teacher. Yeah. No. Good question. Parentheses. The only time you need to use parentheses if you don't use the EE key. If you use times 10 to the whatever, parentheses, especially if it's on the bottom. It won't work at all if you don't have parentheses, it's on the bottom. Because I never use parentheses. Because I would use EE. Huh? And you key it in? Right. It's fine to do that. It's just that you don't need it. The calculator figures it out. Do your calculator have EE on it? Right. Well, 10 to the X is sort of the same thing.
Yeah, that's what I think. As a thought.
Do a problem with scientific notations in the denominator, using it, and then see if you get the same answer without parentheses. Huh?
When we get into the lab.
Yeah. Yeah. And then see if you get the same answer. And if you get the same answer, don't use parentheses. Because that's what EE is 10 to the whatever.
Yeah.
Okay. So this is what a pilot does. Now there's a crash of a 737 up in the Northwest where they refueled in Canada and they used liters instead of gallons. And the plane ran out of fuel, crashed. True story. So this whole metric thing, the guy made a crash landing and no one died, or I think maybe a few people were hurt, but no one died. But it could have been disastrous. Okay, so what's given? The only number in there is the 34, right? And as soon as you saw the per again, as soon as you see the per again, it's a fraction. Okay, so we're starting with a fraction. I'm going to end with a fraction. Okay, so again, there's two problems. Let's do the top one first, liters to gallons. So liters to gallons. So 33, 37.85. Okay, so that gets the gallons on top right away. Now we need to convert the seconds to hours. Okay, so seconds needs to cancel. And then minutes needs to cancel. Okay, so I'm going to do multiply everything on the top, divide by everything on the bottom. Planes use a lot of jet fuel, especially like a 747. They use a lot of jet fuel. I just read an article about Air Force One, and it's the only 747 that can be refueled in flight. They wanted to make sure it could stay up forever, as long as the fuel tankers could fly. Big assumption. So interesting. The SR-71 had to be refueled within like 10 minutes after it took off because it used so much fuel taking off. It was crazy. And they used to fly those over at Beale Air Force Base. They're pretty cool. My dad was in the Air Force, so I grew up around planes, and I was in the Air Force. So I was an avionics guy. And so I really liked planes a lot, aviation stuff. Anyway, all right. Are there any questions about that one? Fraction to fraction. Okay, the last thing I want to cover today is what happens whenever we have square stuff. So this would be square. Okay, so we know that 12 inches is in a foot. Well, how many square feet? And we're going to back up. How many square inches are in a square foot? Okay, to do that, we're going to square this whole thing. And that means the exponent applies to everything. So we have 1 squared foot squared equals 12 squared inch squared. So we end up with 1 square foot is equal to 144 square inch. We're talking about cubic. Same thing's going to apply. We cube the whole thing, so we end up with 1 cubed, foot cubed, 12 cubed, inches cubed, or 1 cubic foot has 1,728 cubic inches in it. So if you notice over here, there are no square or cubic conversions. So you have to know how to create your own. Okay, so what's given? 49.3 square meters. Now I'm not going to square the 49 because it's already been done for me. It's part of the given. We want to end up with square inches. Okay, so we need to go how? Everything's got to be squared now. Everything's got to be squared. So what do you want to convert to first? Well, let's look at our conversion chart over here. Well, we're working with square inches, so we can work with either square feet or square centimeters. What do you want to do first? Well, if you go meters to feet, feet to inches, how's that? Okay, so how many feet are in a meter? Your conversion for that? No, there's no conversion for that. So which one are we going to use? Huh? Oh yeah, here it is. It's $328. Okay. Okay. So what do we have to do to that conversion factor so that the meter squared cancels? Square everything in there. So that means it's 328 squared, feet squared, meters squared. Okay, now we're at square feet. And that was not boldface, so that means that's 3 sig figs. Okay, now we need to go from feet to inches. And again, we have to square it so it cancels. Okay, now we're at square inches. Now, you've probably never done this kind of a problem before. It's just a little different way to look at it. Okay, so how do we do this problem on our calculator? Well, we're going to go 49 times 328 caret, oops, caret is exponentiation 2 at 3.28 squared, or your calculator may have a squared button, depends on your calculator, times 12 caret 2, and there's only ones on the bottom, so we don't have to worry about that. So we're looking at 3 sig figs. And this here you may depend on your calculator, how you put that in. Yeah. I'm sorry, did you say, should I square the 49? No. The reason is it's already been squared as the given. I already told you it was square meters. And a lot of students ask that very question. Everything else you got to convert yourself. Okay, and we do something very similar if it was cubic yards or cubic inches. Same deal. And I think there are maybe, for sure there's one problem. But who finished the dry lab? Is there more than one? Huh? How many problems were there with squaring cubic?
Oh, sure.
I think one for sure. Are there more than that?
Just one.
Just one. Yeah, and so you're not going to see very many of them, but you need to know how to do them though. Okay, that's what I wanted to cover today. Are your so this is where we are right now. Okay, any more questions about? I need to, yeah. And then before you do that, we'll write like that.
Okay, that's what it is.
That's the tricky part about,
Yeah,
because otherwise it thinks it's an exponent.
and then is this have infinite big bags or would it have two?
Two,
The 34 liters are given for here. Two?
yeah.
It's presumed to be accurate. Okay,
Do these make sense? Pretty much,
these make sense.
yeah. Am I gonna update them all? I'll have to go through them and see which ones, yeah, I'll, do that. Thanks for reminding me. Right, right. Helps me planning too. Okay. I will see you guys tomorrow. It's gonna cool off tomorrow too. Yeah, just a minute. Let me turn off the recording. Huh?
Turning in the laptop. That's what's already.
Yeah.